Hey guys, my name is Reno, and today I'm going to be teaching about rotations. Alright, so first off, what are rotations? So rotation is a transformation in which a figure is turned about a fixed point called the center of rotation. Rays drawn from the center of rotation to a point and its image form the angle of rotation. The image is the altered figure. So as we can see here, this is the point P, and these are two rays drawn to the point Q of the image and its pre-image. That's the angle of rotation right here. A rotation about a point P through an angle of X maps every point Q in the plane to a point Q in its image so that one of the following properties is true. If Q is not the center of rotation P, then the image QP and pre-image QP are going to be equal, and this angle measure is going to be equal to X. Or if Q is at the center of rotation P, then pre-image Q is going to be equal to image Q. Alright, so drawing a rotation. Draw a 120 degree angle rotation of triangle ABC about point P. Pause the video, give it a shot, come back for the right answer. Alright, so first off, if you're going to want to draw a segment from P to A, or any of the vertices you decide to choose, and then we're going to put our point, the small dot on our protractor on point P, and the line on segment PA. And then we're going to find the 120 degree rotation and draw a line segment right there. And then now we're going to draw image A, and from pre-image A, that's going to give us the first rule that we learned earlier, that after image AP is equal to pre-image AP. And then we're just going to keep repeating that for vertices C and B, and that's going to give us our new image. Alright, so coordinate rules for rotations about the origin. So when a point A, B is rotated counterclockwise about the origin, the following are true. So for a rotation of 90 degrees, A, B is going to become negative B, A. For a rotation of 180 degrees, A, B is going to become negative A, negative B. For a rotation of 270 degrees, A, B is going to become B, negative A. Alright, so graph quadrilateral RSTU with vertices R, 3, 1, S, 5, 1, T, 5, negative 3, and U, 2, negative 1, and its image after a 270 degree rotation. Pause the video, give it a shot, come back for the right answer. Alright, so now at your back, use the coordinate rule for a 270 degree rotation to find the vertices of the new rotated figure. So we learned that the 270 degree rotation is gonna swap these and make the first number in this negative. So R is gonna become 3, 1. It's gonna become 1, negative 3. S is gonna become 1, negative 5. T, negative 3, negative 5. And U, negative 1, negative 2. This is how it's gonna look in a coordinate plane. This is our original figure, and this is our altered figure. Alright, so rotation postulate. So a rotation is a rigid motion. So what does that mean? What does a rigid motion really mean? A rigid motion means that all the length and the angle measures are going to stay the same. So whenever we rotate a figure or a segment, it's not going to change, and the angles of the figure or the length of the segment is going to stay the same throughout. Performing a composition. Graph RS with endpoint R, 1, negative 3, and S, 2, negative 6, and its image after the composition. So as we learned, a composition was two or more translations. So the first translation, reflection across y-axis, and the next, rotation 90 degrees about the origin. Pause the video, give it a shot, come back for the right answer. Alright, so now at your back, so that's going to be, okay, so this is our original figure. So what we're going to do, reflect it across the y-axis. So we're just going to make all the x coordinates negative and the y coordinates stay the same. Now we're going to rotate it about the origin. So this is going to be our point P technically. And then now 90 degrees. We're going to use our rule that we learned about. We're going to swap these two and make this positive, and that gives us our rotated figure. Alright, so identifying rotational symmetry. So a figure has rotational symmetry when the figure can be mapped onto itself by a rotation of 180 degrees or less. This point is the center of symmetry. So as you can see here, this is the center of symmetry. So all these angle measures are less than 180 degrees. And as you can see here, 90 and 80 and 0, they all look the same, but 45 does not. And this is what we mean when we say rotational symmetry. Whenever we rotate it with the angle measure less than 180 degrees and it looks the same as previously, then that has rotational symmetry. Alright, so rotational symmetry practice. Does the figure have rotational symmetry? A. Parallelogram, B. Regular octagon, and C. Trapezoid. Pause the video, give it a shot, come back for the right answer. Alright, so now that you're back, the parallelogram does have rotational symmetry. It has to be rotated at 180 degrees for it to return to its original position and nothing less. The regular octagon has rotational symmetry and it can be rotated 45, 90, 135 or 180 degrees and it will always return to its original position. And the trapezoid does not have rotational symmetry because you need to rotate it more than 180 degrees, 360 degrees, for it to return to its original position. So if you guys found this video educational, leave a like, subscribe, come back for more educational videos like this.